All right. Hello, data scamps and data champs. This is Richie. So, Java is one of the most popular languages overall, but also one of the most popular programming languages for software development. So, it runs everything from your Android mobile apps to enterprise level software. And it's got a very powerful and mature ecosystem of tools working with data. But until now, we've almost been entirely ignoring it at DataCamp. And the reason for this is that data analysts and data scientists traditionally tend to prefer Python or R or SQL. But two things have changed our position recently. And so DataCamp is about to launch our first Java course. So this is coming out in September. And the first reason is that data engineers actually do use Java. And secondly, data is being used in more and more software applications. And that means that the lines between being a data scientist and being a software engineer are becoming blurred. And so Java is now a useful skill. If you want to call yourself a full stack data scientist, then Java is one of those skills that you need. And so today you're going to get your first taste of using Java, and we're going to focus on a data example. As Reese mentioned, you do need to install a Java IDE on your computer. So we recommend IntelliJ IDEA. You want to make sure to get the community edition. That's the free one. Otherwise, you're going to be asked to pay for a license. You don't need to pay for it just for the purpose of this code along. Okay, so if you've not started downloading and installing it, please do that now. Now, our guest is Bogdan Flores. He's a senior software engineer here at DataCamp. And Bogdan helps build DataCamp's learning platform, so the one that powers the courses and projects. And he works on distributed programming, databases, and building scalable applications. And he's also got a background in AI. And previously, Bogdan was a software engineer at Bloomberg. So, very highly credentialed. And please do take it away, Bogdan.
All right, thank you, Richie. Hello, everyone. My name is Bogdan. I'm hosting from Bucharest, Romania. It's sunny here today, so hopefully this will be a good code along. As Richie mentioned, we're going to cover a very introductory example in Java. And we're going to build, hopefully at the end of this code along, a very short example on how to process some data in Java. But before that, I want to run through some small introductory topics on the language. First, what is Java? Basically, this is a high-level language. It's object-oriented. I'll cover that later. It's designed to have a very similar syntax to C and C++, but with the added benefit that it has safety built in, so you cannot crush programs using Java. This is platform independent. It basically means that you can write it once and run it everywhere on any machine that runs the Java virtual machine. And it has been built because software was getting very large scale and enterprise at the beginning of the 90s. And people needed a language that is better suited to write more complex software that can run on every machine. It's used in everything, basically. It's used in web applications. It runs Android. The whole thing is written in Java. It runs a lot of enterprise applications. It runs desktop applications on both Windows, Mac, or Linux. And more recently, it's become very popular in data. That is mostly due to a few very large data engineering packages that have been written in Java. Most popular probably is Apache Spark. And people have started to embrace this language because Python has a few deficiencies. It is a pretty slow language. Basically, everything that deals with data in Python, it's actually C packages that run it in the background, and for this matter, people have chosen a middle ground in which they can write everything in one language that is still pretty fast to run, but still easy to understand, like Python. So first, I'm gonna go through the Java program structure. The most important thing that you need to remember about Java is that everything in it is a class. You can't have random functions or random variables spread around the program. Everything needs to be contained in the class, and classes interact with each other. The entry point of the program is called the main function. There can only be one main function in the whole Java application, and it's where everything is started. Yeah, this is shown here. This is the example hello world, the most common example. If you remember, in Python, it's one line of code. Here, you can see it's much more. That's because of the class usage. All right. Earlier, I talked about object-oriented programming. What is it? It's a programming paradigm centered around objects rather than just defining a few functions. It was invented because programmers needed to abstract more and more complex domain logic, and C programs and C++ programs were getting very, very complex and hard to understand. It has some core concepts, basically what I talked about earlier, kind of. One's called encapsulation. It's bundling all the data that is related to an object into one thing. Just to give you a very short example, we'd see it later, but a very short example would be, let's say you have a class vehicle, and then you want to have some attributes in it that say the number of wheels that the vehicle has, or how much it consumes, the gas mileage, stuff like that. Another core concept is the abstraction. It wants to hide complex implementation details and only show the essential features. There's the concept of inheritance. There's this mechanism where one class inherits fields and methods from another. For example, if we go back to the vehicle example, a car, for example, would inherit from a vehicle because a car is a form of vehicle. And the other core concept is polymorphism. This is a bit of a hard topic to cover now in an introductory course, but I'll cover it shortly. This is the ability of a method to do different things based on the object it's acting upon. Let's say you have a method drive for the vehicle and for the car. It does different things based on the class that it's acting upon. Yeah, this is basically how Java classes and objects work. This is a short example. Class is a blueprint or a template for creating objects. See, it has like the model here, the year in which the car was made, and how you use it. You have to create a new object, and then you can assign values to the fields of this object. All right. One more piece of concept that I want to cover, which is important for what we're going to do today, is accessibility modifiers. It basically defines who can access some fields or methods in a class. Public means that this is visible to all other classes and packages. Private means it's only visible within the class. And protected, that's a bit more complicated one. This is visible within the same package and in the subclasses. Like, for example, think back to the car and vehicle example. The other thing is static versus non-static. Every method and field in a class can be prepended with the keyword static. Static means that this is class level, and non-static means that this is instance level. I'll show you an example of this later. For example, here's a short example on access modifiers, and if you see in the car example here, we put the model as private. This means that this cannot be accessed from outside. So this example here would not work. And we have some setters and getters. This is how you usually structure a Java program around the fields. Again, this is the brief overview of inheritance that I showed you earlier. A car extends the vehicle class. We won't be covering this today in the example, but it's a very, very important thing to know about Java. And if you want to learn more about this, stay tuned for the Introduction to Java course that's coming out soon on DataCamp. All right. If anybody has any questions before we start coding, now's the time to ask them. All right. If there's no questions, then
let's go.
To the repository. This is the Java code along repository. I've made it. I'd like you to all clone this repository locally. If you have Git installed, you can just either click on code here, either HTTPS and SSH, copy it, and then clone it locally. All right. I'll clone it myself as well. There we go. I've cloned the repository locally. We can cd to it. Now I have this locally. If everyone has IntelliJ downloaded locally, I want you to open it up. You'll see this welcome screen here. You can click on, I don't want you to click on new project because we don't need to do that. It's already set up for you. You can just click on open. Navigate to where you downloaded the repository. I have it here under personal workspace, personal Java code along. Just click on the name, the repository, and just open it. This is the repository now open. One more thing that I want to add. If anybody wants to has any questions and wants to show me his code or something later, please feel free to check out your own branch. I'll find your name. I can navigate back here to this. I'll find your branch, and then I can give advice here. Then if there's no...
Just a quick question. So if anyone doesn't have Git set up, is it possible to just download the zip bundle from from GitHub and then extract that? Will that work?
Yeah, of course. That works as well.
Yeah. So if you don't have Git installed, then if you go to code and then download zip and then just extract that zip file, that's probably going to get you set up quicker if you're struggling with Git cloning.
Indeed. Yeah. Thank you, Richard. If everybody's set up with IntelliJ and with the repository, we can start coding, I guess. Basically, the idea of this small exercise is to get you familiar with the Java syntax, and hopefully by the end of this, we'll get a program that reads some CSV data. It's some small weather data data set that I've made. It's called weatherdata.csv. It's here. It's very, very simple to remember. It's just date and temperature and humidity. And then compute some statistics on it by the end of this. Cool. Let's get started. All right. This is the structure of the program. I split it up into exercises so that it's more easy to digest. The first one is just going to be understanding some basic data types and variable assignment. Then we'll create our own weather data class. After that, we'll learn how to actually use it, instantiate it, basically create an object out of a class. Then we want to analyze the data of a single day, so it makes it simple. Then we want to analyze the data of multiple days. And finally, we will build a short program that reads the CSV data from the file here and uses all those building blocks that we've defined here to get our program running. All right. This is exercise 1. This is about basic data types, a variable assignment. There's a few steps here. You can follow them along and code it with me. We want to declare an integer variable named day number and assign it the value 12. We're going to declare a double named temperature and assign it this value. And we want to declare a string variable named weather description and assign it this value. Then we want to print everything to the console. So let's start. All right, let's declare the first variable. This is going to be day number. I'll type it out. It's going to be 12. Then we want a double named temperature. It's going to be 28.5. And then we want a string called weather description. And this is going to be sunny. How do you print variables? It's pretty easy. You have system.out. This is the print stream. And then you have a bunch of methods called print line. They're here. We can just do day number and use string concatenation like this. Let's not spend that much time typing. Copy the thing. Temp feature here, and then weather description. Weather description. All right. If you want to run this program, you can click on this. This will run main.java. You can also press Shift-R. That's the same thing. I've already set up the main function here for you. This calls out all the exercises with some headers before it, so they're easily distinguishable. If you run it, you can see here, we have, let's make this a little bit bigger so everybody can see. We have exercise 1, and we've printed out the day number, the temperature, and the weather description here.
Oh, could you just talk me through, because you had that system.out.println piece of code. So that looks like a lot of code for printing something out. It's just print. Yeah. So just talk me through like what's with the dots?
This is basically to you're calling out methods or fields of a class. As I mentioned earlier, Java is all about classes. So this is the system. This is a built-in class, meaning that we don't need to import it anywhere here. This is just a class that's provided by Java in the JVM. Here, we're calling out the field out of it, meaning that this goes to the output stream. For example, there's other streams here. There's the in stream that basically reads from the command line, and there's the error stream. That's the these are the three streams that you can print to. And then finally, on that stream, we call the method printline. And then this method does exactly what Python does when it says print. That's it. Does that answer your question, Richard?
It does, yes. All right, thank you. So we're going to be doing a lot of system.out.println just to see what
Oh,
all
yes,
our
of
results are.
course. Yeah, this is one issue with Java that people don't like. It's a bit verbose, as you can see here. It's a bunch of lines to just print something. One difference from Python, you can see you have to specify the data types. You don't just assign day number, so just delete that day number, and this is going to be 12, and then Python guesses that this is an integer. You have to actually specify this. This is a more descriptive way, and it makes the language faster because the interpreter doesn't need to do all this calculation in the background for you. And by the way, for people that are interested in differences between Python and Java, I actually have an example at the end of this program. I've built the same thing in Python, and I can show you the difference in running time between the languages and why you'd want to actually use Java, because it's so much faster than Python. All right, let's get to exercise 2. Now we want to create the weather data class. This basically means that we want to put the weather data that we have here. We wanted to have it encapsulated in a class, so it's easy to work with. The weather data class should have the following fields. It has exactly the same things in the CSV. We have date, the temperature, and the humidity. I've already set up the class here. We just have to fill it in. And we need to add the fields. We need to add a constructor, and I'll show you exactly what this means in just a second. And we have to generate the getter methods for each of these fields, because we'll make them private, because this is how we built a Java program. So you don't want the fields of a class to be accessible out from the outside. You want people to use getters to actually get the data. All right. We don't need to do anything here. I just put it as a doc string. Can implement the weather data class above. All right, let's start it out. So we wanted the 3 fields. We want to make them private, as I mentioned earlier. We don't want anybody to have access to them besides the actual weather data class. We want to make the data string. Again, this is going to be a private, it's going to be a double, and this is going to be the temperature. And then finally, we have the humidity. Cool. I mentioned earlier a constructor. What is a constructor? It's basically kind of what the name says. You want to use this method to construct a class and to make it into an object. We'll declare the constructor public because this needs to be accessible from the outside. A constructor is always named. It looks like a function or like a method, but the name is just the name of the class. And then we want to pass the parameters in. Date, we want double the temperature. We have double the humidity. And then we construct the actual weather data class. So this means that we're going to be calling this. That date is going to be date. And this is basically what self means in Python. It just gives you a reference to the underlying object in the class. So you're not using this date here, you're using this date here. So we're gonna assign these fields. All right. And then we finally have the humidity. All good. We have all those fields. Now the class is constructed. Now we will need to actually set some getters, because if as you remember, we made this field private. So if we do something like object equals new weather data, you won't be able to actually access object.date otherwise, because they are private. So let's create them. We'll make them public again because they need to be accessible. All getters in general are named with get. See, IntelliJ is already completing this for me because this is a very pattern in Java, and it's basically what just returns this one date. You can also omit because this you don't have a reference to a date. You can just omit this, and it will still be the date. Let's create it for the other ones. Get temperature. I'll use IntelliJ to complete this for me. Good guy, IntelliJ. And finally, we'll return the humidity. And this is our class. This is exercise 2 covered. And now we want to actually use this weather data object in exercise 3. We want to create an instance of the weather data class and use it to store and retrieve the weather data. We won't be doing this from the CSV. We'll just assign some objects. Let's do it. So how you create an object, you need to specify the data type. The data type is going to be weather data. Let's say we name it weather data again. And then how you create a new object is you specify new. And it's going to be new weather data. This accesses the constructor. And you need to pass all this, all the data that the constructor requires. We have the date, we have the temperature, and we have the humidity. Let's just pass some values here. 2024, I guess, we're in August, and it's what, the 15th? Yeah, I think so. It is currently 36 degrees here in Bucharest. I know it's a bit hot. And the humidity, I have no idea what the humidity is. So I'll just put something here. The weather, now we have an object. As I mentioned earlier, you won't be able to, let's print out the fields first. You won't be able to specify the field directly. So you need to do it through the accessors. So the date is going to be weather data, and then we can call the methods here. This is going to be date. All right. 1 second. Yep. We'll print the temperature as well. And finally, we have the humidity. Cool. We have an object now. Let's print it out. Let's run the program. As you can see, on exercise 3, we have the data we have set, the temperature, and finally the humidity here. All right. Maybe I've been going too fast. If anybody has any questions here, let me know. If not
so much a question, but it's interesting to note that so the class is for one row of your, is told one row of the CSV file, right? Because you've got
yes.
the 3 objects. So I guess often in analytics you think of things column wise, but this is more you're thinking row wise in the CSV
Exactly.
file in
Yes.
Java. Okay.
Yeah, you want to think this one is an object. This one is an object. And finally, at the end of this program, we'll put them in a list and operate on those individually.
Okay.
Cool. Now, let's go to exercise 4, analyzing a single day's weather. I'll show you how to manipulate the data in a class. We'll do this not directly using by manipulating the fields there. We'll do this through methods. This is usually how object-oriented programming is supposed to go. So we want to add a method called is a hot day in the weather data class that returns true if the temperature is above 30 degrees. We want to add a method is humid day, which does the same if the humidity is above 70. And we want to then use these methods to see if the weather data that we have is hot or humid. Cool. Let's start it out here. We'll go to our weather data class again. We'll create our fields. This is going to be public again because we need it. It's going to return a Boolean value, and it's called is hot day. All right. This returns true if the temperature is above 30. Like this. Now we have is humid day. Cool. This returns if the humidity true if the humidity is about 70. These are all our methods. Let's actually use them. I'll copy the example that I had from earlier, the weather data. I'll copy it down below here. And let's print them out again. Is hot day is going to be all right. Humid day, we call it out, the function. And finally, we can run the exercise. And apparently it is both hot and humid today, which is not a good combination. So why do we want to do this? Because we want these methods to be reusable. Imagine if, for example, we did something like, instead of is hot day and calling this method, we could do something like Boolean is hot day is weather data that gets temperature, and this is going to be bigger than 30. Now, this thing is not really reusable. You'll have to type this out every time. This thing is much better. You can visualize exactly what the method does, and you can reuse it in all of our programs. This is what Java is all about, encapsulating information inside of classes, so it's reused later. Cool. Let's delete this and move on to exercise 5. Here we'll work with an array of weather data objects and calculate the average temperature that we have over all these days. You remember we have all this information about the weather data. Now we want to encapsulate everything in an array list so that we can work on it. Let's do that. Let's first create an example here because this will be easier. This is how we will create a list or an array, how it's called in Java. This is the specification. This means that the two brackets, square brackets, means that this is an array, and weather data is the array of weather data. We'll call it data for now, and this is going to be, we'll just assign 3 objects to it. Let's say weather data of 2024 08 15, then 36, and then 75. Perfect. Let's copy it down. Cool. Let's modify the values a little bit. Let's say 16 and then 17. Hopefully it gets a little bit cooler in the coming days. And the humidity, let's say 70 and 65. This is an array of weather data objects. Now we need to calculate the average of the temperature over these 3 days. Let's do that. We can call average temperature, and then I've set up a helper method here that we'll want to implement in just a second, but we can call it now. I'll just return 0. We can pass it the data, and then as I have shown you earlier, we can print it. Average temperature and put it here. Cool. Let's actually compute this average temperature. As you know, an average is just summing and dividing by the length. Let's do that. We'll compute a sum here. This is going to be 0 for now. Now, this is the first. One of the first control flows that I've shown you. This is a for loop. We want to navigate over all the weather data objects and get their temperature into the sum. So, usual for loop. Let's say day. This is going to be the data. This is how you usually do a for loop in Java. And then sum is going to be, we'll add the temperature of the day to the sum. And finally, to return all of this, we need to divide the sum by the length, by the number of days, basically, the length of this array. Cool. This is how you compute the average of the temperature. Let's run it. Bam, we have the average here in exercise 5. Cool. And now we've built all of this. Now let's actually read this weather data, the CSV data inside of our program. We'll do this manually so that we can learn how to read the CSV data. And then we'll actually calculate the average temperature on the CSV data directly. So we'll reuse this thing that we implemented earlier. This is what I mentioned about reusability. This is why you want to encapsulate logic inside of methods. And then we'll use this method that we need to implement. This reads the weather data from the CSV file. Cool. Let's first put a skeleton together in analyze weather data here. The read weather data returns a weather data array. So let's get it from here. This is going to be, let's call it the CSV data. This is going to be read weather data from CSV, and then we pass it the file name. Now, the file name is the weather data _data.csv. I've put it at the root of the project because then you don't need to specify the path, and hopefully you won't have any problems with path specifications because they're different in Mac and Windows, and it's better if you put it in root so you can just do it like this. Cool. Then we want to compute the. I'm mistyping. Average temperature. We'll use the function from above. We'll pass the CSV data, and as I have used you, we can just print it. Average temperature from CSV, and this is going to be average temperature. Cool. Now for the last part of this code along, we'll need to actually read this weather data from the CSV, and I'll make use of some built-in classes and methods that are in Java, so everybody can use them. You don't need to install any packages. The first one will be the buffered reader. The buffered reader means that you can store a buffer of data inside of it and read from it. Cool. First, let's declare our array list. This is another way to specify an array like this. But I'm using array list because it's much easier to work with. Array lists can be dynamically resized, so you can add more items to it. This basically is like a list from Python. So for people who are coming from Python, this is exactly it. And this notation right here with the square brackets, that means that this is an array list of weather data. We're gonna call it weather data, call it list, and then we'll just create a new array list object. So array list is a class, and then we'll create an array data list. This is going to be an object. Now let's use the buffered reader, and we'll use a notation that is familiar to people who have used Python. This is called try and catch. We're going to try to read this file name, and it might not be found. If it's not found, then the try will error, and this is why we want to use the try catch. Let's first import the necessary things. We've already IntelliJ already imported array list here. Let's import the other things. We'll need, as I said, buffered reader, this one, and then we'll also need the file reader. This actually reads the file. So as you'll see, we'll read the file and pass it to the buffered reader. Cool. Let's write the try catch now. We're gonna try to create a buffered reader here. This is going to be a new buffered reader, and we need to pass it what it actually reads. So this is going to be a new file reader, which we have already imported, and here we can pass the file. All right. This might not be imported. No, we need to actually handle the exception. Here, we're trying to catch an IO exception, I think. Yeah, it's this one. This is how you catch an error in Java. It's basically very, very similar to Python here. And if we get an error, just let's say we just print it out for now. This is not how you're supposed to handle errors usually, but this will do for now. Hopefully don't get one. Cool. We have a buffered reader now. This one here, the BR variable. Now we want to read all of this data into a string. Let's say we want to read this file line by line. So we want to read this, and then this, and then this, and so on and so forth. We'll put all of the data in a string called line. We want to first, so we don't need the actual headers of the CSV, so we'll skip those. So we just put a comment here and say, let's say we read the line. This basically skips it. And now we want to iterate over the other fields. So line is going to be br.readLine, so we're reading again, and then we want to make sure that we're not reading an empty line. So if we're reading an empty line, so if line is null, this while loop will exit, and the program will stop. All right. We have a line. This basically means that in this variable here, we have one of these. So what do we need to do? We need to split it. Split line into the actual fields. And you can do this by creating an array of strings. Let's call this data. And then we split on the comma. Now we have the data here. Let's assign it to some objects. We want to extract the values, basically. The data will be the first. Let's rename this variable because this is split line. Let's call it split line. The date is going to be split line of the first element of the split line. Then we have the temperature. We need to get that out. We need to parse this actually because now Java thinks that the temperature is a string, so we need to parse it from a string to an actual double. So how we do that? We call double dot parse double, and then you can pass it a string here. There's going to be split line of 1. And we have to do the same thing, but for humidity. Right. And this is going to be split line of 2. Finally, out of all these things, we can create a weather data object. Pass it data, temperature, date actually, temperature, humidity. And finally, now that we have the weather data, we can assign it to the list. And how to do is you just call the add method on the list, pass it weather data, and finally, we have our CSV parser. Pretty cool, right? Finally, we need to actually return it. And because we want actual Java arrays here, we need to cast this to an array. Cool. We have our reader.
Oh, I have 2 questions for you about the reader.
Cool.
We're a bit short on time, but we'll have to do this quick. But you made use of this new keyword when you were creating the buffered reader and the file reader. Can you just talk us through, like, when do you need to use new? What does it do?
The new keyword basically is used only. This is a keyword that's used only when you want to create an object out of a class. So if you remember, in Python, for example, let's say you do um, data is going to be weather data and just this. This is how you create an object from a class in Python. Now, Java requires us to actually add the new keyword. And this new keyword tells the Java compiler to search for the weather data constructor. And it goes to this and actually creates the object. This constructor returns a weather data object out of it.
So you just need it for things where it's a class, but you wouldn't need it for I'm creating a new integer or a new string.
So only when it's a class. So you need it, for example, because string is actually a class in Java, you need it for strings. So you need to do something like that. But for integers, you don't need to do it because integer compared to a string, integer is a built-in thing in Java. Strings are not. Strings are classes.
Okay, got you. And the second thing is, so we've gone into quite low-level code for reading in the CSV file. Would you do this in a real-world project, or is there some kind of library that you could use in order to?
There are libraries that you can use for sure. I don't remember them by heart, but
is it joinery?
Joinery, maybe. Yeah, I think that there was. Oh yeah, I have it here. You can use this to basically this is an abstraction on data frame. Make this larger on data frame from Java from Python, but in Java. There are multiple ways of reading CSV files, but people in Java actually like to do this sort of stuff because you can optimize it and make it faster a little bit. Some things are very tailored towards one use case, and Java luckily has a lot of built-in things to easily read and work with strings. But yeah, there are multiple ways of doing this. Like Apache Spark has one way to read CSV files, and it's much faster than something like Joinery, for example. But if you want to have an abstraction around Python, Joinery is a really good choice there.
Okay. All right. Nice. Yeah, we'll go to audience questions in a moment, but I'll give you a minute to wrap up.
Yeah, we're basically wrapped up because we've implemented this reader. We've already done this analyze weather data method. We have the calculate average, just putting it all in one place. And exercise 6, we have the average temperature, 29.89, blah, 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 here. Cool. Questions?
Right. Nice. Actually, that was absolutely fantastic. I love that we kind of went from just scratch to building in something to read in data. So before we go to audience questions, got a load of upcoming code alongs. So tomorrow we've got a session on building effective dashboards in Tableau. Make use of the QR code in order to register for these. Next Tuesday, we've got a session on building responsible AI agents. And then Wednesday, the session on introducing Microsoft Fabric. So lots of different technologies to get your hands dirty with. All right, so we're going to go to some audience questions. So first up, Brody asks, slightly abstract question this. So lots of different ways you can take this. What do you think of the use of chatbots for this topic? I guess, do people build chatbots with Java?
Yes and no. You can do it easily. There are quite a lot of tools. There's this really cool deep learning for J library that is used to build all kinds of neural networks. I've used this myself. It has a lot of things built in. It is a NumPy implementation for Java, an Apache Spark integration. You can do it, but I haven't actually seen this in the wild. Java is mostly used for number crunching. It's getting data from one format to another. Um, and why? Because it's faster, but still easier to work with. If we have time at the end of this, if there are no questions, I can actually show you a difference between Python and Java for this.
Okay, yeah. So the big advantage then is around like messing about with Spark and doing some data engineering. Then, uh,
Exactly.
all right. I guess the other way of interpreting that question is like, can you make use of generative AI to help you write Java code? So in the same way that you can use it for like Python, does it? I've heard people like complain that a lot of the sort of less popular programming languages don't work as well with the code generation, but I presume Java's popular enough that
Java is
it'll.
very popular. It's ChatGPT and your favorite GPT is going to work very fine with Java. Yeah, there are some really esoteric languages like Zig or Campbell or some random stuff that I've delved into that don't really work with chatbots, but Java will definitely work.
All right, super. And next question comes from Klaus. So Klaus asks, are there any tips for making use of IntelliJ IDEA to write faster Java code? Any shortcuts, libraries, plugins, anything like that?
Yes, a lot of them.
It's
But
probably several hours of webinar in itself.
yes, yes, very, very much so. I've actually taken the time to actually type this out because I wanted everybody to understand the code that I'm writing. But it's very easy in Java to do stuff like and just type this out with auto completion because it's very, very good. You can integrate Copilot here if you've used that, and it will help you speed things out a lot. I'm using Vim shortcuts. This is what's helping me write this fast, but I don't recommend this for beginners. This took me a while to learn.
Okay, so I presume, is there a standard autocompletion? It's just like hit tab and
Yes,
go
this
out.
is standard on IntelliJ. You can configure it for every editor, but IntelliJ is quite literally just the best at this. There's nothing that compares to it. I don't recommend any other editor if you work with Java.
Okay, nice. That's all for audience questions. So we've got 1 minute left. How quick can you do the comparison with Java
Let's
and
see.
Python?
Let's run it in. I've basically made weather data a file here that is pretty big. It has like 50 million lines or so. It's about 1 gig. And let's run it. It's gonna run. Should be. I've timed it at some point. It's about 7 or 8 seconds. Yeah, it's done. Now I have the same implementation in Python. It's here. This one. Let's run it as well. And this is gonna take a while. This is gonna take around 30, 40 seconds. So this is the difference between Python and Java, and this is why you want to use Java for things that are data intensive. It's still running.
Okay, and the Java one, it was less than a second or something to run, was it?
It was around four or something.
4 seconds.
Five,
Okay,
yeah.
so we got a 10 times speed up then from
Yeah,
using
so
Java.
this is still running, by the way, if you can see it, like it's not wrapped up, unfortunately.
Okay, nice. I don't think we'll wait. Oh, there we
32.
go, 30 seconds. All right,
Yeah.
so that's a pretty decent speed up from
Yeah.
using Java. All right, with that, we are at time. So thank you so much, Bogdan. I felt like I learned a lot. So I used to do C# programming back in the day, and it was quite
Oh, really?
nice to see how like the Java syntax is very familiar from that. But
It is.
yeah, very cool stuff. All right, and thank you to Reese for moderating. Thank you to everyone who asked a question. Thank you to everyone who showed up today. I hope to see you again tomorrow for the Tableau session, or perhaps next week for one of the other code alongs. Please do register for those. See you all again soon.